Today's lecture is continuing in 1.3 with transformations of graphs. Today we're going to be talking about reflections. And so there's two types of reflections that we call, and one of them we call reflecting essentially into the x-axis, and the other one is reflecting into the y-axis. Okay, so I'm using y equals the square root of x because when I'm doing reflections, sometimes if my graph has any type of symmetry, like y equals x squared, for instance, then sometimes all of the symmetry, when I do a reflection, then I don't really, my graph sort of gets picked up and put back in the same place. So since the square root of x is just in the first quadrant, we really get a sense of how all the reflections work together. So I'm going to apply it to the other ones at least generally, and so we're going to just start with this. Okay, so the first one that we're going to talk about is the reflection. Sometimes I say, or in general, we say over the x-axis. This is actually technically not correct. It's more of a reflection into the x-axis. So this is the y equals the square root of x, and I have another one that's exactly, now I just changed my color. The way that I reflect over, right, or into the x-axis is to apply a minus sign out here, right? If you think about it, I want it to come down here is what I'm doing. A reflection means it's going to have a mirror image down here into or over the x-axis. And in order to get negative y coordinates down here, all these y's would have to be negative. So we put a y, right, or we would just put a negative in front of the square root of x, like this. And boom, just like that, I have the blue line, which is a reflection into or over the x-axis, okay? So when I put a minus sign in front of the function itself, it reflects it downward. Now this applies as well, even if I shift this, okay? So let's say I just want to shift this reflected, let me take this minus sign away here for a second, and instead I want to write in here, I'm going to write the graph of x minus 2. I want to shift it 2 to the, actually let me put plus 2. Let's move it to 2 to the left. So I'm going to put plus 2 underneath here. Remember the lecture from the previous lecture tells me how this translates my graph 2 units to the left. So it's the same graph, it's just now to the left. And again, the same thing happens if I put the minus sign here, then it just essentially flips it on its axis. Wherever this starting point is right here, my graph just goes in the opposite direction. It's just exactly the same graph, it's just reflected, okay? All right, so let me take this away and put it back to where it was. Okay, we take this one off. Okay, so now what if I wanted my graph to be over here? Right? This would be a reflection into or across or over the y-axis, right? This is y. So what if I wanted the exact same mirror image but over here? Well, that would require a domain restriction change, right? Because my domain for the square root of x is as x has to be greater than or equal to 0. And so I'm going to need to change what I'm allowed to put into my function. So that means essentially that my minus sign, right, minus signs are always involved in my reflection, actually goes underneath my radical here, okay? So if I put a minus sign in here, now it's not graphing it yet because I don't have it checked. If I put a minus sign in there, then that means that my domain restriction will be negative x is greater than or equal to 0. And when I multiply or divide by negative 1, whichever you prefer, then I get really the opposite, that x would be less than or equal to 0 because I have to flip my sign. And so that means that my domain will be on the left side over here. So when I check this box, I get this combination. Okay. All right, and so I've got, oops, let me put the minus sign back out here. Okay, so I've got graphs in all 3 quadrants, okay? So this is my original square root of x, this is negative the square root of x, and then this is the square root of negative x up here. And so how do I get it down here, right? Well, it would actually be the reflection over right, or into the x-axis of this graph here, which is the square root of negative x. And so if I put a minus sign in front of this green graph, then I should end up down here. So let me take this one here. Now, initially, I have no negatives inside of it. And so I'm going to make it this one here. So that now that's this blue one here is now the one that I'm trying to reflect over. And so since I want it to be downward, I'm going to put the minus here. Okay? So again, this is the square root of x, right? This is the negative square root of x, right? So a reflection down goes in front of the function itself. A reflection across here across y is a minus sign underneath or inside of the function itself. And then to get it down here is basically a double reflection, a reflection across x and a reflection across y, both. All right, so let me take away, all right, the square root of x. And let's work with x squared, okay? So to reflect it downward, okay, into the x-axis or across the x-axis, we sometimes say, then that is this case up here, right? The y equals the negative square root of x. That means we put the minus sign in front of, right, the x squared, okay? And so when I put the minus sign in, it just essentially takes and it just rotates it right over across the x-axis, right? So a more interesting one here is x cubed. So this is the original x cubed. Let me just rewrite this one so you can kind of see them both. All right, so y equals, I'm going to make another x cubed, and I'll put my minus sign in here in a second. So again, x cubed. So when I'm rotating it across the x-axis here, now this time I have a piece down here and I have a piece up here. And so when I rotate it, essentially it's kind of like I'm going to hold on to both pieces and it'll rotate up. So essentially what's going to end up happening when I put my minus sign here then will be this picture, right? So whatever, if it's down here, it ends up here. And if it's up here, then it ends up down here, right? This piece, okay? So these are the two graphs. So when I put a minus sign in front of my function, then that is a reflection, basically, kind of we say downward a lot, or into the x-axis, across the x-axis. Whereas if I put a minus sign inside, that's when I get across y. Now, y equals x squared, okay? That's y equals x squared. If I wanted to reflect it across the x-axis, what do you think is going to happen? Well, this has symmetry, right? And we call this an even function because it's exactly the same on both sides of the x or the y-axis here. It's y, not x, sorry. So this has symmetry. And so when I reflect it across the y-axis, basically I'm going to pick up my graph, flip it over, and it's going to end up looking like the exact same thing. So that means if I would put, and I have to use parentheses here, if I'm trying to reflect it across y, then essentially I need to say, let me just add another one down here, y equals, the parentheses, negative goes inside of the function, squared, right? There's no difference, right? In fact, the orange one now turned blue. They're exactly the same. So, and you can also think of it algebraically. If I square negative x, then negative x times negative x is going to give me positive x squared. And so that's why I chose the square root of x, because that's the only one that shows all of the symmetries. So this one, when I reflect it across y, it doesn't look any different, right? It's exactly the same graph. So I only see the reflections in this one when I reflect it across the x-axis with the minus in front. Okay, take that one off. Let's play with y equals x squared a little bit, okay? So I reflected this one. This one, the black is the original function, and the red is the reflection over the x-axis, right? The minus is in front. But you'll see here, again, this doesn't show both either. If I put y equals and I try to reflect it across y, so that means I would plug it in negative x in my set of my parentheses, cubed, then I have the exact same graph as my original reflection across x. The green, right, the red one turned green. So this is the new reflection. And that's because you can kind of see, well, one, if I take negative x and cube it, I get negative x times negative x, which is positive x squared. I multiply it by a negative x, and I get negative x cubed. And so algebraically, it's exactly the same thing as this one here, the y equals negative x cubed. Okay, the red line over here. And basically what will happen, again, this is my original function, and instead of, right, when I reflected it downward, this piece became this piece, and this piece became this piece. But when I reflect it across, the black one here becomes the green one on this side, and this black one here becomes the green one on this side. But essentially, it doesn't really matter because it's exactly the same graph as y equals negative x cubed. Okay, so again, we can see one of the transformations, but not the other, because they look exactly the same. All right, so let's talk about one more case. Okay, so let's take these other graphs off of here. All right, so let's work with the quadratic function, and we're going to take the quadratic function and move it 1 to the right and 3 up. So 1 to the right would be x minus 1, right, is my standard form, and I'm going to, because I said quadratic, so I need to make it squared, and then 3 up would be plus 3. Okay, so there is my shifted graph. Right? So I don't have any reflections in here at all. Okay, but I just want to show you. So let me copy this and put this back down here so I can play with it a little bit, so that way we can see the original function. Okay, so what I'm going to do first is reflect it downward, right? A reflection into the x-axis. Now it doesn't jump, right? It's just a pivot on its vertex there. So if I put the minus sign here, right, I get the exact same graph. It's just now tipped downwards instead. So where I plug when I put the minus sign outside of my function, right, it just, wherever the function is originally, it just takes it and reflects it in the opposite downward or upward direction. All right. So now when I try to reflect it side to side, really over y, then when I do that, I put the minus sign in here, but when I do, it changed, right? So when I put the minus sign in here, really, it's with parentheses. So now I can see, wait, it's not, it's exactly the same graph, right? Just shoving a minus in front of the x actually isn't enough. It'll actually alter it. So we put the minus on the inside of the function, and it ends up being exactly the same, which it should be, right, as in our thoughts. Right, so if you have any questions about these, the reflections, right, go to Desmos.com and play with putting the minus signs in here. Again, this works the same way on all of the functions we've talked about. The square root of x, the cube root of x, right, x squared, x cubed, and the absolute value of x. It also, don't talk too much about the constant function and the linear functions, just because those are easy to graph without worrying about the transformations. All right, until next time.